Hmm. Hi to all of you. I can see some users coming here. Okay, let me see. I'll be here for some time. For 5 minutes, I'll wait. I'll take the class in next 5 minutes. Okay, I can see Pauline is telling that there is some network problem. Okay, at any case, let me see. Okay, I can see Pauline is telling that there is some network problem. Okay, I'll start the proceedings. Okay. Now, below on the description, you will find in the description you will find the link sites.google.com Synod College. Okay. Uh, if you browse the site, it goes like this. Okay, I'll just minimize my screen here. Okay. Okay. So you can see the screen. Okay. Okay. If I'm lagging, also not a problem. Okay. Uh, my video will go in some smooth way. I'll just show you the site. Okay. To get this slide, you just click here sites.google.com view Synod College. Okay. Below in the description, I have given sites.google.com/view Synod College. You click on BCA. Once you click, you will get there something called as notes. On the notes, you see the second semester DS. Click over there. Apart from unit 1 notes and all, you will see this unit 1 array and its representation. Okay, you can get this slide from here. Okay, if you want to see these slides later. So if there is any problem in the video I am lacking, you can get it from there also. Okay, now I'll just start this class here. Okay, in our previous class we have seen array and its representation. We have seen what is an array. This is a one-dimensional array we have seen in the previous class, and this is a two-dimensional array. Now we have also seen how we calculate the length of the array. The formula was this. Then we have also seen the representation of an array in memory. Okay, then we have also seen how to find the location of a particular element. So this was the formula in case of a one-dimensional array. Okay, now today we'll be discussing something on two-dimensional array. So today's topic is, now in case I have given you the problem before to find this 1965. If you have done, you can see this one. Okay, it's there in the notes. You can find the answer for this one. Okay, now we'll start this topic on what is called a two-dimensional array. Fine, any problem still here? So this is the topic for the day. Explain the representation of a two-dimensional array in memory. Explain row major and column major representation. Okay. Okay. Uh, if any issues, you can just I'll just pause for a minute. If any issues, you tell me. If I'm lagging, you just tell me. The location of a particular, the formula in case of a one di. Okay, if everything is fine, just tell me, I can start. Okay. Okay, I'll start now. Okay. Okay, suppose I have this array like this. Okay, I have an array like this. Suppose its name is suppose A. Okay, now the first index of the array is always denoted by say 0. The second one is always given by 1, 2, and so on. So it is up to, so it goes like this. Okay, say up to n elements are there. So this is a one dimensional array. So we call it as, so in short I'll write as one dimensional array. Fine. Okay, so each element is kept in the next sequence. First element comes here, suppose this is 2, and the second element is suppose coming here is 7, the third element is coming here is -1, the fourth element coming here is 0. Okay, so all these elements are kept inside the array up to n. So this is basically a one dimensional array. So we have seen its representation in the previous class and how to find the location of any element k. Suppose you want to find the location of this k, in the previous class we have seen this. Okay, and I have shown you the formula. Now today's class we will be doing something called as a two-dimensional array. Now a two-dimensional array basically looks like this for our picture. It has rows and columns. So these are the rows and these are the columns, right? So we call as this is the 0 row, this is the first row, this is the second row, and so on. So we call this one is the first column. Okay, so 0th column, this is the second one column, this is the third column, this is the fourth column. Okay, I hope there are no issues or no questions. Yeah, in case. Okay, fine. So I'll continue here. Okay, so this is basically a one-dimensional array, and this basically is a two-dimensional array because it consists of rows and columns. Okay, let me bigger my screen now. Okay, now if we visualize a one-dimensional array, it looks something like this. Okay, suppose if I take this box here and I draw this one, this is a one-dimensional array. It has rows and columns. Okay, this is basically a one-dimensional array, and if we visualize a two-dimensional array, it will look something like, I mean, if I take a box here, this will be a two-dimensional array, just for your repetition. Okay, okay, two-dimensional array will be something of this nature. It will have, sorry, not this one. It will have, firstly it has the rows, okay, like this, and it will have columns like this. So this is a two-dimensional array. Okay, coming back to the slide here, I'll just show you. You can see that this is a two-dimensional array. Okay, the number of columns here is 1, 2, 3, 4. The number of row here is 1, 2, 3. Okay, I don't think if there is any doubt in this issue here. Now, if you have noticed one thing, in a one-dimensional array, the first element is given by 0 index, the second one is given by 1, the second one is 2. Okay, but in case of a two-dimensional array, the first element of the first row is given by, this is 0, 0, this is 0, 1, this is 0, 2. Okay, this is 0, 3. Now it goes to the next row, it becomes first row. This is 1, 0, this is 1, 1, this is 1, 2, this is 1, 3. Okay, I hope there is no issue on this thing. So a one-dimensional has a single index, the two-dimensional has a double index. Likewise this. So the first element is 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1, 2, 2, 2, 3, like this. Any questions here till now? Because this is the basics, it has to be clear right now. Okay, this is 0. Okay, now I go ahead a little bit with this one. Okay, you're only supposed to understand one thing here. Basically, what does it says is, if this is a one dimensional array and we have numbers from, say, the first index is 0, the next one is 2, the next one is 3, the next element is kept at the fourth index, and finally the last element will be kept at somewhere at an nth index, an index. Okay, fine. In case of a one dimensional array, so there are n number of elements in this array, and also this will be divided like this. Again, the same thing. This is the 0 index, this is the 1 index. I divide it as 2, 3, 4. Okay, and it is up to n, that is there are n number of elements. Okay, now when I have the same thing in terms of a two-dimensional array, what happens here is, you see again, this will be the first row, this will be the second row, this will be the third row. Say the first row is 0, the second row is 1, this one is 2, and likewise there will be n number of rows. Okay, just like the same here, up to n number of elements. So 0, 1, 2, 3, 4, up to n number of rows. So is the first, the second column, likewise it will go up to n number of rows or n number of columns. Okay, now usually this will be this column, the second column, the third column. Okay, up to m number of columns. Okay, so this is a matrix where we have how many rows? N rows. And how many columns? M columns. So this will be called a matrix of n cross m, or an array of n by m number of elements. Okay, so if we have 4 rows, 3 columns, that means 4 multiplied by 3, it will be 12 number of elements can be stored there. Okay, so this is important. N means the number of rows, m means the number of columns. Any questions here? Now I just pause. If you have any question, just type in the question there. Okay, I'll just pause and I'll watch and look. And if you don't have any question, just tell me, sir, there's no questions here. And it is, Yeah. Any questions? If you have any questions there. Any confusions? Can I proceed from here? Okay, I just proceed from here to the last part of this. Okay. Now, this is just a one-dimensional array. This part, this is a two-dimensional array. Okay. Now, I'll just erase this board now. Okay. I need to have a okay. Now, suppose if I'm keeping elements in this form, okay. Say I'm keeping the students in a list like this. Say A, B, C, then P, Q, R. They are coming, okay. And I'm keeping in this fashion. First of all, I created a row RST, okay, and I'm keeping all the students like this. Suppose these are the list of students. I'm keeping it somewhere, okay, and I'm keeping like this. This is the first row, A, B, C, P, Q, R, some, then P, P, okay. Then after some time, I made another row, and I'm keeping in the next row. Suppose, okay, something like Q, then R, T, Y. Then after some time I decided again I'll make a third row and I'll keep them in a third row like this. Say, okay, this is one way. Another way, it's this is not clear. I'll just show you one thing here. Suppose I keep elements like this, 1, 3, 8 in and 7 in the first row of the array, okay. Then I keep the next element is 2, 1, 4, 6. Then in the third row I kept the elements -1, 0, 2, 14. Now this is my array of 1, 2, 3, 4 columns and 3 rows. So it becomes how many? 3 by 4 matrice. So this is an array of 3 by 4 mn, okay. Now I'm keeping elements here in a row wise matter, is it? Firstly I go with the first row, then I kept them in the second row, then I kept them in the third row. This is what we say is row order, ORDER, okay. This is called a row order. It's ORDER, okay. Now we have another form which is called as a column order. When we keep elements in the form of a column, we call it as a column order. Suppose if I have kept elements in this form, say first I created 1, then I created 3, then I kept here 7, then I go to the next column 0. That means I'm filling the column first. Say I kept here 11, -2, -7, okay. Now this is a column order. That means firstly I'm filling the elements in the first column, and once it is done, then I'm keeping in the next column, then going to the next column. So this will be called as a column order. It's called a column order. Okay, so this is the only topic here. What is row order and what is column order? In a two-dimensional array, if we keep elements serially row by row, it's called a row order. That means we first fill the first row, then it's called a row order. If we fill in the column order, that means if we first fill the first column, then we go to the second column, then it's called a column order. Okay, so you can check your notes there and also read today the presentation of two-dimensional array in memory. Okay, so for today we have done this one. That's the only topic, what is row order and what is column order. Okay, now that's the end of the topic here. If you have any questions, just type in. Okay, okay, call as a column. Two-dimensional. Okay, I stop here. Now you can go to the link, this sites.google.com. Dolphy has just asked me, sir, this link. So sites.google.com. I can show you this one. Uh, sites.google.com/view/college. Click on BCA and click on notes. Click on your paper DS second semester. This particular presentation will be present there itself. So this is the one, unit 1, array and its representation. Okay, so that's the thing there. sites.google. Okay, so okay, we'll see tomorrow. uh, do get the slide and read it. Okay. Okay then, thank you all. So I stop here. If in case if you have any questions, you can WhatsApp me or you can give me as a comment here, or you can send me a message. So the class ends today. We'll see again the continuation of the next part. Okay. Thank you. God bless you both.